What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be starting a completely new tutorial series, in the Python programming language. So essentially, this tutorial series will be our MatPlotLib tutorial series. So it is basically a data visualization tutorial series. So that's what we will cover in this series of videos. So since this is the first video in the series, essentially what we will do is we will just talk a bit about the package itself, and really there is not much to talk about the package because majority of the concepts and I would say features of the package, the only way in which we will learn about the package is by actually physically implementing it in Python. So that's what we will do. We will just begin this series with a small discussion. I will walk you through the installation process, as well as we will just see one or two examples of simple graphs to plot. So nothing too strenuous for this video. So MatPlotLib tutorial series. Now, MatPlotLib is a plotting library. When I say plotting library, guys, I mean it's a data visualization library. So data is represented in many ways. Okay, there are several ways, forms, representations in which you can format or structure that data, and matplotlib allows us to obtain a visual representation of the data. Now, you see, logically speaking, right, we as human beings, we infer and we kind of reason and deduce out of patterns and trends. When we analyze patterns and trends, that's how we are able to make conclusions or deduce, certain statements. Now, Matplotlib offers us the ability to actually take that data and visualize it. Okay, so we can plot it on a simple set of axes, which is basically our Cartesian plane. Now, data, let me actually complete typing this comment. So data visualization in Python. Now, you see, matplotlib itself is a very interesting package. Essentially, the aim of this tutorial, the reason as to why I'm creating this series is because matplotlib is a very vast package. Okay, by vast I mean there's so many options and features that you can play around in the package or with the package. Like, for example, the most important thing that comes to mind when you hear of matplotlib package is graphs, okay, charts, ways to represent or structure that data. Now, regarding something simple like a bar graph, for example, there's so many different features and style options and formatting options. So really the aim of this tutorial series is to take you from a beginner, a complete matplotlib beginner, up to a professional or advanced matplotlib user. Okay, and we will cover majority of the plots. I think all of the important plots will be discussed in the series. I will show you simple styling options and so on, and yeah, we will have fun working through this tutorial series. So that's enough of discussion. I am actually waiting to just get hands-on with this package. It is a super interesting one. So before we actually begin, right, you guys know before we actually use something, we need to make sure we have it. So what you can do for me is head over to your terminal of choice or your IDE or so on, and I want you to type pip install matplotlib. Now, if you have Python installed on your machine, the chances of you having pip on your machine is very high, okay, because pip usually comes as a feature with any Python installation. So what you guys can do for me is actually head over to your IDE, type pip. If you get some sort of output, that's good. As you guys can see, I do get some sort of output. If you don't want to just type pip, what you can do is just type pip -v, and if pip is installed on your machine, essentially you will be returned with the version of your pip. And if you don't feel like doing a capital letter V, on a single hyphen, you can do a pip double hyphen and the word version in lowercase letters. The output will be the same. Essentially, if pip is on your machine, okay, you will be able to use its features. So what I want you to do for me is type pip install matplotlib. And after you have that statement, you may go ahead and press enter, wait for a few seconds or minutes and so on, and your your pip will install the matplotlib package for you. So I already have it installed, so it will take a few seconds and it will tell me like requirements already satisfied. We've been through this before. Pip is your friend when it comes to installing packages in Python. Okay, so in the meantime, essentially, just to give you a bit of insight, right? This tutorial, I am anticipating it to be quite lengthy because, guys, you see, on the channel itself, right, my goal is to thoroughly cover each and every topic that we work through. Okay, essentially, to put it simple, I am trying my best not to have to revisit a topic, in the future. Essentially, if needs be, I will definitely recreate a few videos or add-ons and so on. But my point is, all these kinds of tutorials where I take you from beginner to expert, all the concepts should be discussed in one single flow of videos. Essentially, I'm not going to be scattering the videos on the channel and so on. So that's just a small insight for you. Anyway, now that we have matplotlib, I want you guys to also make sure that numpy is installed on your machine. So what you can do is just do a pip install numpy just to be sure. Essentially, if you are following along from the NumPy tutorial series, then you will not have any issues with the packages and the setup of the videos. So that's fine. Now the reason why I told you to install NumPy is because you see, guys, matplotlib itself, right? Matplotlib, yes, it's the plotting library, but we need data to plot those visualizations. What good is visualizing data when you don't have data to work with? So essentially, we will utilize a few of NumPy's features just to give us that fake or dummy data to actually work with. So that's enough discussions. The way in which we will learn more is as we progress, we will discuss and continue to do that. Now let's get hands-on with this package. So I've shown you guys how to install the matplotlib package. That is done. Now, if you are curious, right, you see matplotlib is used for scientific and numeric plotting. Okay, we have covered a tutorial series on scientific and numeric computing. It's the tutorial series we've just concluded on the channel. Now, matplotlib makes an appearance when it comes to actually taking that numeric and scientific computations and visualizing it. Okay, and it makes it super straightforward. There's nothing difficult about it. You've just got to understand, I would say, the Python syntax, and that's something that you guys know we do together, on the channel. So matplotlib is a kind of modern solution, okay, to visualize our data, and it has a very good balance between the ease of use for the users as well as the computational power that it brings. Now, essentially, what I would like to do for you guys in this video is just demonstrate a few concepts. We will explore a few of the importation ways and so on. So let's get to it. Now, for this first example, what I'd like to do for you guys is plotting one curve. A curve is a very common gradient or distribution that we encounter, especially in the real world. Your parabolas, hyperbolas, your sine graphs, cos graphs, and so on, they are all over the place. So essentially, let's just get to it. I want you guys to import matplotlib.pyplot as plt. That is the, in inverted commas, default way in which you will find that matplotlib is imported in Python. Okay, so oftentimes in your journey with Python, you will encounter this line of matplotlib. It's the importation. So You guys know, right? For any graph or distribution that we work with, we have x values and we have y values. So essentially, suppose I would like to keep it simple. I am using a simple range function of Python. I'm setting x to be equals to that. Now, that's going to give me 100 numbers, essentially from 0 to 99. So now I need y values. Y values would basically be some function, some equation. Okay, I spoke to you guys about this in the previous videos. Essentially, you don't need to pay attention to the standard or raw Python syntax that we are familiar with, right? Where you see the creation of variables, the range functions, and other standard Python syntax, that is not important. What's important is that you focus on the matplotlib portions of code. So all I'll do for the y values is I will have some sort of uh, iterable. It's a list essentially. You guys, if you are taking the MatPlotLib course or this video series, I assume you guys are familiar with basic Python syntax. So value multiplied by 2 for value in x. Now, this is known as something called a list comprehension. If you are new to Python or you've just not encountered this specific usage of lists, it is known as a list comprehension. And they are very powerful, and I highly recommend that you look into it. So I have x values, I have y values. Now I may actually plot my straight, or rather I would plot a line graph. Now to plot a line graph in matplotlib or using matplotlib, we will utilize plt.plot function. Okay, plt.plot. So I'm heading over to my IPython console. As you guys can see, I will just do the importation has actually not been done yet. So let me just run this. And now I will do plt.plot. And I just want you guys to just have a look at, the documentation. There is a lot, but I am going to simplify it. Essentially, I just wanted to bring up these parameters. There's a lot of them, and we will definitely explore in the future. For now, I am showing you or demonstrating to you the base level features or functions of matplotlib. This is your introduction, your core introduction into the package. So essentially what we have here is the plot function. And you guys know, right, in the real world, when you are working with a line graph, for example, right, the number of x values you have needs to be equals to the number of y values you have. Okay, you cannot be plotting a graph containing maybe 100 data points, 100x data points, and you're plotting 80 data points which belong to y. So what I'm saying is that the representation needs to be the same. X and y needs to have the same shape or the same number of elements. Okay, I cannot take 10 x values and plot 5 y values. If there's 10 x values according to mathematics laws, if there's 10 x values, there needs to be 10 y values. There's a corresponding y value for every x value. So if that makes sense, and I do hope it does, essentially what we are passing to the plot function is two important arguments. We are passing the x and the y data points that will be plotted on our axis. So I have plt.plot plot x, y, and now I will do plt.show. Go ahead guys, run the script, and if you look in your IDE or appropriate software, you will see the visualization show up. Now I am going to discuss with you guys more features, more functions. So I think the way in which we also can go about doing this is if I code the code first and then I explain after, but we will work around what we have and we will see how it goes. So essentially what you guys can see, there's a sort of image here or plot that shows up, and we have the graph that has been plotted for us. Now pay attention guys, you see The x-axis has values from 0 to 100. Well, 100 will show up, but essentially this graph, the gradients or the x values, the roots, they basically stop at, the domain stops at 99, right, included, because of that range function. And essentially all that y, the y function, the function of this graph is basically f of x is equals to x squared, right? Value is basically representing x. Now that's what we have here. So this is a curve graph. It's a typical graph we encounter in math. It's an exponential graph. Y is equals to x squared. Now that is what we have there. Now I am going to assume that you don't have any Python experience, right? This is just my assumption. I'm assuming you don't have any Python experience, and for this question only, or for this demonstration, I'm going to explain everything that we just did in these, what, 5-6 lines of code. The first line we see is import. Okay, this tells Python that we are using the matplotlib.pyplot sub package or module. You can call it whatever you like. Now, to save typing the extensive name of matplotlib.pyplot, we imported with an alias of plt. So anything we'd like to reference from the matplotlib.pyplot sub package, we may access it using plt shorthand notation. Now, that's fine. In the second list, or in the second line of code rather, we see this list object which is created by the range function of Python. It's going to contain or comprise integers from 0 to 99. Right? The range function, you guys know, it generates consecutive numbers for us. Now, the next line we see is y is equals to, and that list comprehension. So essentially what's happening there is a new list is created, okay, and this function, basically you can think of it as a function. We are applying this function, this square function, to every value in the x list. Okay, every value that is contained in the list, which is x, is going to be propagated into y, but with a small tweak to it, which means we are squaring each number. Okay, and I told you guys, you call this a list comprehension. Do Google it, read up on it. It is very, very interesting. So what we see afterwards is the fourth line of code, which is plt.plot x and y. Now, that is the line of code which actually does the plotting of the curve for us. The x coordinates of the curve's points are given in the list x, which is what we have here, and the y coordinates of the curve points are given in the list y. Okay, and the name that you give to the list. So here we just named it x and y. I should mention that you guys can name your ones anything you like, any name, because essentially these are variables. Okay, so you may name yours anything you like, and that's that. So that was kind of a walkthrough we had, kind of the basics. I hope you guys found that interesting. Now, before we actually round up this video, so suppose now I'd just like to give you a small demonstration of matplotlib package in which we use NumPy. So we can work with a much more fancier graph. I will give the equation for us and you guys can code along with me. So what I'd like to do now is, suppose we'd like to plot another curve. I've created a new cell and I will import the modules or sub packages constantly because of the fact that I just have new cells. Okay, and to make the script much more understandable for you guys, so you guys can see the importations being done. So we will probably work with one in which we utilize NumPy. First, I'd like to demonstrate to you the math module. So math is a built-in Python module. You guys don't have to install this package. Just go ahead and type import math. So what I'd like you to do next is import matplotlib.pyplot as plt. That's the importations. You guys can comment the code if you'd like to. So let's go ahead and let's set up our values. So what I'd like to do now is basically set t is equals to range of 100, x is equals to, I will create a list comprehension and I will say 2 multiplied by math.py multiplied by t. This is the x values. Guys, we are simply making a tweak or a change to the x values. So all divided by length of t for t in t. That is a list comprehension. I will not be explaining that. Next, let's set up the y values. So another list comprehension, math.sign of value for value in x. So essentially we are just taking those values generated in t, those simple values 0 to 99, and we are transforming them to become our x values, which as you can see we are taking 2 multiplying by the pi value of pi multiplying by t, and t is basically taking on each number in that list, and we are performing a slight division. So that is x and y. If you guys want to also view what x and y look like, you guys know that you can. Okay, feel free to experiment and just go crazy with your Python code. So another curve which will be plotted, plt.plot x y and plt.show. So if you are wondering, right, plt.show, you may be probably wondering why we call plt.show. So essentially what it does is that it kind of ends the instance or the plotting instance that we are working with. Okay, so if you have been following along, you guys saw, right, in the previous tutorial series, essentially I gave you the logical explanation. I said, you guys know, in the real world, we can take one sheet of paper, we can take our pen, and we can plot 10 curves on a single axis. Okay, that's what we can do. Now, Python supports that as well, and plt.show kind of tells Python or MatPlotLib that we are done using this paper. So any other curves that show after plt.show has been called will basically be shown or displayed on a new canvas, okay, on a new set of axes. So I hope that makes sense to you. Now, that is fine. Now, the next thing I'd like to do is, obviously I want to run this and I want to show you guys what we have. So as you guys can see, we have a curve. This is a kind of shortened version of a sine graph. So as you can see. So let's try one with NumPy. The NumPy package is also very handy. You guys know when it comes to creating fake or dummy data, NumPy is there for us to utilize. So import NumPy as np, and I'll actually just copy this. I'm a bit lazy to type that again. So there we have our matplotlib. Again, let's generate that x and y values. So let's do a numpy.linspace, a function we covered in the previous tutorial. And what we can do is multiply by numpy.py. And we would like 100 values. So that is the x values. 0 to 2 multiplied by pi, that's basically the limit, 2 times pi. And within that boundary, we'd like 100 values. For the y values, what we can do is a simple numpy.sign of x. And you guys know it's a sine graph. So plt.plot, we are doing x and y, plt.show. Nothing would happen if I forget to, put show this line of code. Let me just undo that. Yeah, so if I forget to add plt.show, nothing would happen, right? You see the graph is actually showing. The two graphs we worked with are the same. So let me clear that and I'll run them again so you can see. This was 1 and that was 2. The graphs are the same. So essentially what I'm trying to say is, you see plt.show, nothing will happen if I, don't put this line of code. But as I explained to you, okay, suppose I have two graphs. I have this graph here as well. Now, what would happen? Assume that they were different curves, right? By having plt.show here and by having plt.show there, what happens is, as you guys see, I get two different visualizations, two different graphs. Okay, plt.show, that's why I explained to you. It kind of tells Python that we are done using this piece of paper, give me a new one. Now, that's when I have two plt.show. But now, let's take out this. Let's move this there and just assume they were two different graphs. And if I run this, you guys see we get two different distributions, two different graphs on the same paper, on the same canvas, same axis. Okay, so that's what plt.show does. And you are probably wondering, right? The graph is usually blue. Why is the graph orange when we have two distributions on it? So what you will notice as well is that when you have several distributions, several gradients or curves that are plotted on the same piece of paper, which is the canvas basically, MatPlotLib has been designed to automatically make life easy for us and give every curve a new or different color from the next. So as you can see, three curves, and assuming they were different, we'd see them scattered all over, right? Because of the fact that these are different, the colors are kind of being overlaid, okay, on top of each other. So interesting stuff. That's that. So I will clear these plots for now. That's what we have with NumPy. As you guys can see, NumPy is on the spot, on the go. We can just easily generate some data for us to work with. So if you guys would like, more examples, NumPy, you guys know, we covered what is broadcasting. Broadcasting has been covered on the channel in our NumPy tutorial series, and this is what makes NumPy so powerful, especially when you combine it with MatPlotLib, because generating data is not a mission. You can do a simple plot of data in less than 5-6 lines of code. So import NumPy as np, import matplotlib.pyplot as plt. So as you guys can probably already see, right, this series will be different from the ones we encountered. In the previous ones, we did discuss some theory, but I mean, not everything will take that format. For certain things, will be required, kind of be compelled to first get the hands-on experience with the code and the way in which it works, and then we can take some discussions. But majority of the concepts we're looking at now, NumPy, mathematical stuff and so on, we have covered. Okay, so the only thing, as I said, that should be new to you and you should be focusing on is matplotlib syntax. So let's do one more example. X is equals to numpy.linspace. Suppose I'd like my values to be -3, 2, and I'd like 200 values within. The y values, I can set them to be equals to x to the power 2 minus 2 multiplied by x plus 1. So that is kind of a mix there, but that is that. I am sourcing these equations from online resources, so you guys don't have to stress about the equations as well, right? If you'd like to keep a standard straight line graph or a standard curve graph, have one for each type of graph. Have one for a curve, have one for a trigonometry, a straight line, and so on, and you can work with that same equation. Or if you want to go ahead and keep changing and following the equations that I'm giving us, you can do the same. So that's what we have here. Let us plot this plt.plot, and just as a reminder, guys, plt.plot, the plot function gives us the plotting of a line graph. Let's actually add that as a comment. Utilize the plt.plot function to plot a line graph. So I hit Control Enter, and as you guys can see, I have this curve. And just to make you aware, you guys can play around with this, right? So go ahead, change the 2 to 6, make the 200 to 500, and go ahead and plot this, and just observe the curve and how it affects the visual representation. It is super interesting, guys. So let's change that back to what it was. It was 2 and 200. So that is fine. Now, this is where we will end for this video, guys. Essentially, this was just to get, your feet wet, kind of give you insight into what you can expect. And this is super interesting. I find this really very cool. I mean, any forms of technology never cease to fascinate me. So I hope you guys enjoyed the first video in the tutorial series. We will continue just exploring more and more features of MatPlotLib until we reach a point where we are advanced, when using the package. So with that, thanks guys, thanks for watching, thanks for staying till the end of the video. Good luck with your work, and I'll see you in the next YouTube video.